And now, please welcome Brian Stevens, CTO and Vice President, Worldwide Engineering, Red Hat, to the 2012 Red Hat Summit.
Well, there's a new challenge, $5 billion. I think those of us at Red Hat think we can do that, so we're on it. And we especially appreciate the Kimball's gift certificates. For those of us in Westford, that means a lot. It's a cool place. You know, in IT, there's always a challenge ahead. For those of us that are developers, partners, customers, vendors, for as much software as we write, for as many products we build, for as many solutions that we deploy, it's just part of a journey. There's always a long journey ahead. But I think it's important to say that we've come a long ways. You know, it's hard to believe that Linux, and I think in many cases Linux is still considered the new kid on the block. Linux is now over 20 years old, so think about that. And Red Hat Enterprise Linux itself is now celebrated as of this March, its 10-year anniversary. But before that world, before there was Linux and RHEL and AMD and Intel, our customers, enterprise IT, had to deal with siloed stacks of software. And these siloed stacks of software introduced both great capital costs as well as operational costs. And those absolutely got in the way of IT's mission. So it was more than a product. RHEL and x86 really delivered enterprise transformation. What they did is they drove consistency through the stack from consistent hardware, consistent operating systems, and consistent management software. And so even more important than that, they delivered a consistent set of applications and an operational set of procedures independent of the hardware brand. And so therefore, they achieved something that decades of standards activities before them could not. So x86 has absolutely redefined enterprise, and it's actually, you know, is the key enabler for delivering cloud at scale. But these days, we don't just talk about scale anymore. We talk about hyperscale. And so if we're talking about public clouds, it's not just about 10,000 node public clouds, it's about 100,000 node public clouds. And when you start to look at the server designs and the racks that are going to be delivered in the future inside of enterprise IT, these aren't small racks anymore. These racks are being designed for upwards of 3,000 servers inside a single rack. But they're decreasing space by 90% and decreasing power by 90%. So, but in the past, you know, to deliver application availability, it was really all about how do we make the single system and the single application never fail. So you used to hear about things like fault-tolerant computing. And what that did is it made just about every component inside the system dual redundant. And what that did is it might have achieved the mission of availability, but it drove so much complexity into the system, and it drove the cost. And to deal with application scalability back then, it was as simple as how big can we make that one box? More memory, more CPU, more I/O, further increasing the complexity inside the system and driving up the cost. Today, you don't hear about that anymore. Today, what you hear about the avant-garde for scaling applications is across cloud and distribution. And in so doing, as you build cloud at scale and applications at scale, inherently in that comes great resiliency as components of applications and servers can actually fail and application service continues. So even with that, commodity computing, virtualization, cloud technology, it's just amazing that 80% of IT's costs today are just keeping the lights on, focused on their existing infrastructure. But end users like Facebook, look at what they've had to build. Their service became so popular that they had to get across these obstacles. So they invested in new hardware designs and new operational procedures to make sure that they could scale and grow with their users. And they had a couple of options. The first option was keep that as proprietary innovation to themselves. But instead, they decided to share it. So in so doing, they created the Open Compute Platform, or OCP. And what their aim is to share what they've learned around hardware design and operational procedures with the industry. So in so doing, they're really trying to take a play out of the open source handbook and apply it to hardware.
Traditionally in the hardware space, people develop the products in secret and then they launch the products to the world. And they're basically solutions that are looking for a problem, as opposed to really clearly defining the problem statement up front and then developing a solution with the community that's going to eventually consume it. And so, with regards to the Open Compute project, the way that started was we looked back in 2008, 2009 at the trajectory that we were on from a growth perspective, and we decided we needed to grow in a different way, in a more efficient way, a more effective way, because at the time we were using co-location spaces, which is basically leased data center space, as well as off-the-shelf server and storage products. We started designing our own data center, and we also kicked off an engineering project to design our own servers at the time. We got it all into production, we measured the results, and the results were actually better than our high expectations. Taking a page out of the book of open source software, we looked at how fast that pace of innovation occurs in the software space, and we said, wow, what would happen if we shared this? The Open Compute project is really staying focused on the physical side of the infrastructure, so the data centers, the servers, and the storage devices, and specifically within that area, focused on the unique needs of people that are deploying at scale. So the goals of the project, of the Open Compute project, are to really, number one, accelerate that pace of innovation by sharing some of the best ideas that we could come up with. And that's really what the Open Compute project is focused on. There are a number of companies that are already adopting Open Compute, but we also think that the number of companies that this is going to be applicable for is going to grow over time. This trend towards cloud, HPC, scale, whatever you want to call it, it is a growing trend, and so people are deploying at larger and larger scale. There was already a lot of pent-up passion in the community around taking more control over their hardware infrastructure, and so since launching the project about a year ago, we've seen a tremendous amount of engagement from the community, not only from end users, but also from the suppliers in the industry as well. And so we're really hoping that the innovation content can go up because we're really taking an active role in converging those voices from the community. We're really excited about Red Hat's involvement in the project because a lot of customers started to ask, hey, it's great that you're open sourcing your hardware designs, but what should I run on it? In talking to the folks at Red Hat, they were really ready, willing, and able to immediately do Red Hat Enterprise Linux certifications on top of Open Compute hardware. And so that really just gives the consumers of the Open Compute hardware devices confidence that Red Hat will stand behind deploying RHEL on the hardware. And so it's generated a lot of interest, a lot of traction, and so we're really glad to have Red Hat as a friend of the Open Compute project. While it did start with Facebook open sourcing our designs, that whole ecosystem around Open Compute is really starting to take off, and the people that are inspired by the project is really starting to take off, and that's really what I'm excited about, is just in our first year seeing the impact that we've had and envisioning what it could be in the years to come is really exciting for me.
So we're starting to see two interesting trends emerge, right? The first is that data centers are just getting more dynamic. I think it's pretty obvious. So IT needs to be able to fulfill the requests of their users instantly. And if they're not, they have two options. One is to provision a ton of extra resources to support that in a static data center design. But if they do that, it means they're underutilized, and that introduces great cost. And the other alternative is they don't have enough resources, so they drive up their utilization, but then they're too slow on delivering what their end users need. The second trend that we're seeing is really sort of the end of specialization, right? We've already seen this in sort of the application and the compute space, where if you look at the application servers and hardware running in the cloud and enterprise these days, they're no longer the specialized hardware of days gone by. And in the future, we're going to see that exact same thing start to happen both in the storage space as well as the networking space. These future data centers just need to be so much more agile than they are today. IT needs to be at the heart of this and be able to fulfill the requests of their users, whether that be a developer looking for more development resources or test resources, or the ability for more infrastructure to deploy applications, or for more infrastructure to be able to scale out applications, or more storage. So what IT needs to be able to do in the future is to be able to elastically turn a set of building blocks into whatever the mission requires, whether that's more compute, more storage, or more network. At the base of this is Red Hat Enterprise Linux. It's the foundation. It's the very first piece of software that touches hardware, and it leverages this awesome community that ensures that hardware enablement happens, performance, and security. So in the future, a RHEL-based node will be able to become whatever you need it to become, whether you need more compute, whether you need more storage, or whether you need more network. The compute nodes today already take advantage of Red Hat Enterprise Virtualization, So inside a RHEL based on integrated KVM. And what this means is now at the compute tier, not only can you run these robust native applications, you can also run full-on virtual machines, all on the same infrastructure. So whether you want Windows inside of a virtual machine or you want RHEL. In the networking space, technologies like OpenFlow and Open vSwitch are absolutely going to be transformative. And when they appear inside of the future RHEL roadmaps, they'll be able to take RHEL-based systems and turn them into really scale-out networking switches or even virtual switches. And in the storage space, we've already begun. We can take RHEL-based systems and RHEL-based nodes and turn them into either a component in an elastic data grid or actually part of an elastic storage service. You know, we're swimming in a sea of data. Over 2.5 quintillion bytes of data, of new data, are generated each and every day. So if you think about that, that's what we always call the velocity of data, how much data is new data is generated on a daily basis. And it's stressing all of our system designs from front to back. So that the amount of that new data is doubling in less than 3 years, right? Machine-generated data, user-generated data, public and private, from emails to videos to everything. Over 12 terabytes alone of tweets are generated on each and every day. So of this data, the majority of it, over 80% of this data that's being generated is what we call unstructured data, unstructured files. So that really is the genre of the new world's data. So from unstructured files, we need to be able to store it at the velocity it's generated. We need to be able to scale it. We need to be able to protect it. We need to be able to integrate it into applications. And hopefully, we need to be able to harvest intelligence from it. So high-capacity standard databases will still exist and will always exist, but they're unable to deal with the velocity of this new data, the scale-out of this data, and the schema of these databases just does not map into the type of data of unstructured. It's for this reason is why we bought the company Gluster last year. Gluster was all about how do we in software take a common set of RHEL-based nodes and on top of that build a scale-out elastic storage service. And Gluster is completely optimized for this 80% of unstructured data that's being generated. They're completely optimized on high-velocity ingestion of unstructured data. And what's great about Gluster is instead of it saying, okay, here's a whole storage system, and it's a start over, it builds completely on top of Red Hat Enterprise Linux. So the data on top of Gluster is actually living inside of Red Hat Enterprise Linux, inside of the physical file system inside of RHEL. Today, that file system is XFS. And what Gluster does is it builds a unified namespace of files across a distributed set of systems. So as part of that, the users accessing this scale-out storage service are absolutely unaware on which node their data actually exists. And that's because of, inside of Gluster, there's this thing that we call the elastic hashing algorithm. And really what that's about is users can actually, based on the data they want to access, they instantly go to the node on which that data lives. And it's very unique in the industry because in most cases you need the notion of a directory node or a meta node, and you have to talk to that node first before you're able to find your data. And the obviating the need of this directory node is what allows Gluster to scale to the levels that it does. And they have to scale on more than one dimension. So as this velocity of data grows, we need to be able to, on demand, add more storage. And the architecture of Gluster means that we simply add more RHEL-based nodes and make them part of the elastic Gluster solution, thereby adding on the disk space of those local nodes. And then there's other dimensions as well. It's really hard for IT ahead of time to figure out what data is going to be hot. Most of this data is written once and read many. But it's really hard ahead of time. You've got companies like Pandora and others. It's really hard to know what piece of data is absolutely going to be the hot piece of data. But with Gluster, they can respond instantly and replicate the hot data to more nodes and therefore load balance the traffic. And then the other way of scaling is just that the total aggregate access to data might be overwhelming the number of systems that you have in the Gluster solution. So in this case, the other dimension is add more nodes, not just for increasing your storage capacity, but to have more nodes actually serving the data, and it increases the response time. So with big data, now we can store it and we can scale it in a cost-effective manner. But the next step is we need to be able to harvest and mine intelligence out of that. So Apache Hadoop is this fabulous open source project, and I think in many cases it's synonymous with big data. And Apache Hadoop is based on this MapReduce algorithm. So it really takes some of the technologies from sort of the HPC era and it maps a query across a set of distributed nodes that are homing the data. And then the end result is propagated back up to the node requesting the query and reduced down. So Apache Hadoop is in use by, and in some cases developed by, the companies that themselves probably have the biggest big data problem in the industry. Companies like Yahoo and Pandora and Twitter and Facebook. So with Gluster, we can actually, because Gluster is based on RHEL underneath, so it has the ability to not only store the data locally in the file system, it has the ability, because of it's running on RHEL, to actually run compute and applications simultaneously. So Gluster really fits well with this, because now we can take those Hadoop queries and we can distribute them locally across a set of Gluster nodes. And so what we're able to do is we're able to process the data where it is and avoid building this separate cluster just for our analytics. And so the side effect of that is that we have the ability to do extract real-time knowledge out of our tier 1 data set, as opposed to later putting the data somewhere else and processing it in batch mode. So it really is a very powerful combination when you start to think about Gluster and Hadoop as one integrated platform. But not all the world is certainly about scale out, right? We still have these mission-critical applications and databases. Fortunately, Red Hat Enterprise Linux, for many of the people on the team, it's been, year over year of new features and performance capabilities just in support of databases. So Red Hat Enterprise Linux today, out of the box, supports all the open source popular databases as well as the proprietary databases. And when they're based on RHEL with integrated Rev that includes open source KVM, not only can you run these mission critical applications in databases at performance, you also can live migrate the complete application and database to another node with zero downtime. And then later this year, not only will we be able to do live migration, we'll actually be able to live migrate the storage the application is using as well to another system. And it satisfies a different use case where you're actually trying to load balance your infrastructure and move applications and their data to another piece of infrastructure. So the public cloud has been very transformative, and I think it's probably been most impactful on developers. So for developers, it's meant an instant set of resources that they can use, not just to develop their applications, but also to test and deploy their apps. It's been far easier for both developers and others inside of enterprise today to actually be able to use public cloud resources than actually be able to use to get resources inside of their enterprise, which is a little bit ironic when you think about how we always talk about how underutilized existing IT resources are. It's just that IT organizations today aren't fully prepared to build private cloud that measures up to the service that's delivered in the public cloud, but they actually can be and will be in the future. The first part about this is that the footprint, the RHEL and x86 system inside of existing enterprise today for both compute and increasingly storage is very consistent, in many cases identical, with the platform that most public clouds are running on already. So these resources too can be organized into a self-service elastic cloud. What's really missing is the operational management software on top, the operational management software that's actually used to organize them, these resources, build them, and allow IT to manage that self-service cloud. So it's not to say that private clouds today don't exist. They very much do. What we're really saying is that the public cloud and the new private clouds really just share very little resemblance, right? And that's to be expected because the implementation and the code on which they're being built today is not in common. So that means different APIs and different characteristics. So it's our belief that really only an open engine, an open source and open engine, is really going to drive ubiquity in cloud. It was true in Linux, and we think it's going to be again true in cloud. So the project OpenStack is changing all this. So OpenStack is this collaborative open source project that aims to be both useful as building public cloud infrastructure as well as private cloud infrastructure. And today it's only 2 years old, but today there's already a vibrant development community on it, as well as it's garnering great industry support. And hopefully within the next few months, there's going to be an official foundation formed that is a body that's going to neutrally govern OpenStack forward. And then it becomes not just a discussion around what's the API to the private and public cloud, and how do we try to hammer them into being the same. It's actually we now have the ability to build clouds on the exact same open source technology. And so not only will we get consistency through API, we'll get consistency through many other things, including behavior.
We think open cloud is an extremely important concept. Cloud presents a new model for everybody, and one in which we have the opportunity to build something that's different than what's been built in the past. And bringing everybody together, whether it be individual developers or large companies, to innovate together on a common kernel, a common thing that becomes the standard in cloud is extremely important. And the level of innovation that we've seen around OpenStack to date has been truly impressive. OpenStack is a set of software for building both public and private clouds. It's a project that we launched 2 years ago in conjunction with NASA. The goal was to enable any enterprise, any organization who wanted to build a cloud based on a set of open source technologies to be able to do so. One of the real promises of OpenStack and the open cloud is to provide for true interoperability for customers, to be able to deploy a workload and use a workload where you want it, and to be able to have it all work together. So the idea that a customer can have a workload running on an OpenStack environment in their data centers, in a Rackspace data center, and in another facility, and have it all work together is a very exciting thing for us. And we also want to see the pace of development in cloud really take off. And so we made the decision to open source our technology in conjunction with NASA and then a host of other companies, and together build a standard platform for cloud computing that customers can consume wherever they want. And ultimately for us, that is a real differentiator in the service marketplace. It allows us to focus on what we're really good at, which is making sure that the customer environment runs really well and that we're great support partners for them on top of OpenStack. The OpenStack community is very diverse. We have several different key groups that are involved in its development. The first are obviously the developers themselves. We had about 250 contributors to the last release of code in April, but obviously there's significantly larger numbers of developers who are contributing to the project overall. You have a large group of users that are deploying the project today and are very actively involved in contributing to its development. And the third would be the companies that are helping to sponsor the project itself, that are bringing the customers and bringing the developers. Red Hat's a great example. That has gone from an initial launch of two groups, Rackspace and NASA, to now getting close to 200. And many of those are putting significant resources towards the success of the project by incorporating it into their product sets. I think that open source is something that people are excited about as a movement. Developers want to work on it. Enterprises are very excited about what it brings to them in terms of control over their own environments and control over their own roadmaps. We think it's a very important way to develop software going forward. We're excited to see Red Hat commit to using OpenStack as part of their product set for customers. Red Hat knows a lot about enterprise software. They know a lot about infrastructure. We certainly think the expertise they bring to the community about just making OpenStack easier to deploy and easier to consume will be very important as people start to use OpenStack. The long-term future of OpenStack is very exciting. I think the number of companies, the diversity, the fact that we've got such broad representation internationally bode good things for the project. And most importantly, we want to see the promise of interoperability. We want to see those solutions working together so customers can really achieve the true vision of cloud, which is the ability to move workloads around and consume them where they want to. And that's what we're really excited about. It's an area that Red Hat, I think, shares a common vision with the community. We're very excited to see their leadership on it.
So we're getting to an era where we're going to have dynamic capability to put applications and compute wherever we want and put storage and data somewhere else. So really the evolution means we need a dynamic network topology that supports all of that to really give IT the freedom to place data and storage independent of underlying physical network topology. So the future really for this is all about software-defined networking. And leading the charge is yet another open source project called Open vSwitch. And Open vSwitch allows you to build this virtual networking programmatically on demand, independent of what the underlying physical connectivity is. So in short time, Open vSwitch has already become accepted as part of the upstream Linux kernel, which means it's a good foreshadowing that it'll be available in future versions of RHEL, and it's also been integrated inside of OpenStack. So what that means is then, not only within a data center, but even outside of two data centers, we're going to be able to connect applications and data together based on the needs of the mission. And then when you start to talk about, and we've talked about it a lot this week around open hybrid cloud, we need a way of actually not just using public cloud and private cloud, we need a way of actually bridging them together with a secure, agile network topology. And that's really what Open vSwitch is all about.
So if you look at the data center right now, in order to build a large cloud operation, it's really about getting them to run as efficiently as possible and with as little overhead as possible. And the long pole in the tent is networking. And until we virtualize it, we're not going to hit those gains. The network interconnects servers and it interconnects storage, and today the operational model is very, very manual and it's very inflexible. And if you virtualize that, you unleash the potential to have everything automated and everything flexible. So Open vSwitch lives within the kernel on every server. And what the Nosql product does is it stands outside of the server and it orchestrates all of these. And it orchestrates them in a way that it makes it look like virtual networks exist that can be spanned across all of the servers. So we work with customers that run data centers, and I would say that they have two primary problems. So the first problem is resource efficiency, that how if you are a cloud provider, do you run a data center where all of the resources are utilized fully? And the second problem is operational efficiency, which is how do you operate that without requiring a lot of headcount and a lot of operational overhead. And the way that network virtualization comes to bear in this environment for resource utilization, it allows you to place any workload anywhere. So for example, if you have a server that's underutilized, you can move a workload over there. Or when you're spinning up a new tenant or a new application, you can spin it up in any of the pockets that are underutilized. And because network virtualization can be totally programmatic and totally flexible, it doesn't require operators in order to run, which gives you the operational savings. I believe Linux, KVM, OpenStack, and Open vSwitch are really bringing us to kind of the next generation of computing infrastructure. And so we are moving from client server into the cloud. And it's really about making infrastructure software defined. That environment will be open, it will have a platform feel, and it will have multiple parties. And I think these are the core elements that are going to make that happen. We're definitely entering an era where cloud is taking over, and I think that customers are used to looking forward towards Red Hat as the leader in Linux to also be the leader within cloud. And so what they're asking us, and I believe they're asking Red Hat as well, is for a supported platform that allows third parties to provide specialized value, but still have a single cohesive company that's trusted to back it, and that would be Red Hat. Our goal is to reinvent networking. I mean, and until you can buy networking gear in the same way that you buy servers, and they're as flexible as servers, we're not done. And so we're going to start in the virtualized data center, and we're going to virtualize away the fabric in the data center, and then we're going to move out from there.
So not everyone, though, gets to start from a clean slate, right? IT today has typically an existing large set of assets of virtualized applications, storage, etc. So what we want is we want to be able to allow IT to integrate their existing set of enterprise assets together with the assets on the public cloud and knit that into an open hybrid cloud. And so the key to all this is operational management. So the ability to have management that actually is able to integrate with things like on-premise VMware, on-premise Rev, deployments of NetApp, deployments of EMC, and knit that into a cohesive fabric that ends up being this scalable, self-service public cloud, hybrid cloud. So that was really the design center of CloudForms that started many years ago, was not to become a cloud, but to actually be able to allow you to build and operationalize a hybrid cloud. And so it was really around the integration of these assets. And once you achieve that, you're actually able to have a common set of templatized applications that CloudForms is able to deploy across any infrastructure in that hybrid cloud, no matter what the underlying mechanism is in implementation of hypervisor or cloud substrate for that cloud. In addition to the value it gives users, it actually puts IT back in charge, and they have the ability to sort of specify policy of use of the cloud as well as govern it. But from a developer's perspective, right, resources are resources. Developers really don't want to care about virtualization technologies and hypervisors and what a public cloud is built on. For decades, developers are already surrounded by seas of tools. They have to deal with, on a daily basis, with compilers and IDEs, test tools, continuous integration, static analysis. So for them, the emergence of these public clouds, although useful, has just looked like one more toolkit in their arsenal. And so what it's meant today is they have to figure out how to integrate those tools. What are the interfaces to these IaaS clouds? How do I package my software to run it on Amazon? How do I operate it? So the intent of OpenShift is to change all this. OpenShift is Red Hat's platform as a service. And what it essentially does is it integrates the public cloud directly into the developer's sandbox. with the goal of obviating the developer to have to even worry about the cloud at all. They don't have to worry about the API, they don't have to worry about packaging standards or any other interfaces on how to deploy and operate applications. So in a sense, the tool chain ends up becoming a part of the public cloud service. And the technologies behind OpenShift, we released as OpenShift Origin, as the open source project. And the technologies that are included in there are really the best of breed of what's available in open source today. Things like Git for source code management, Jenkins for continuous integration, JBoss EAP6 for robust Java environments, and naturally RHEL 6 for secure performant application hosting. So with this, now a developer really needs only to worry about developing code and checking it into their sandbox, their local sandbox. And OpenShift does the rest. It integrates with their sandbox. When a developer checks code in, OpenShift takes that code, packages it up, transports it up to the public cloud, compiles it or builds it if need be, runs it through continuous integration, deploys it across the public cloud, it plumbs the DNS so that users can access it with mobile and browsers, and then auto-scales it if the users start pushing too much demand on the app. So tens of thousands of developers already are building apps on the OpenShift cloud. And these new developers are often quick to take advantage of new cool technologies that makes their life either better or more interesting. So we start to see things that are emerging like Ruby and Node as an example. And one of the things that developers are gravitating to most quickly in the public cloud space are alternative data stores. So they're looking for alternatives to over 40 years of SQL programming. And so you're starting to see this whole class of data stores put under the category of NoSQL that these end users and new cloud apps are using. And it just gives them a very simplistic way of managing their data, treating it in many cases as just key value or documents. But the architecture of that, not only is it simple, it means their data is easily striped and distributed across a set of disparate cloud resources, so they get both scalability as well as availability. And there's one company that absolutely is has become synonymous with a big part of NoSQL, and that's Tengen, the developers behind MongoDB.
MongoDB is an open source database, a NoSQL database, as they say. So it's non-relational, and the goal of the product is to give you a database that scales horizontally on clusters of commodity hardware. Thus, it works well in cloud environments too. And in addition, to try to make software development easier the way we write apps today. The reason, the inspiration for the project was just writing apps ourselves, getting frustrated with the tools, seeing the same problems come up over and over again, and having to be solved over and over again with workarounds and such, and feeling like there's got to be a better way. And part of that better way is cloud computing. Another part of it, I think, is a big change in database technologies. Developers really like MongoDB. It really fits well with the way we write software today. The dynamic schema nature of the product makes it fit well with iterative development methodologies. So there's this real focus on software development, making it easy, productive, nimble. We like to use the word agile. We think of kind of what MongoDB gives you is both scalability and agility. People are using it both because they can write apps faster and they can scale horizontally on commodity hardware and large clusters. Thus, it's very compatible with cloud computing. We're trying to kind of build the database that we would want to use to write apps. One of the reasons we started the MongoDB project is just because we thought cloud computing was going to be very important, and traditional databases are not cloud friendly. So for us to create something that fits well in a cloud infrastructure was very important. I'm very excited about OpenShift. I mean, for me, PaaS, or Platform as a Service, is a very big deal. A PaaS gives you kind of a full stack that's pre-built, right? And so the way Mongo fits in is by being the data layer in that stack. And the great thing about Platform as a Service is because that's all pre-stitched, you don't have to do all that work yourself. You just write your app and you deploy it to the cloud. We're really excited about Tengen and Red Hat continuing to work together. You know, these themes are a big deal. You know, we're seeing massive transformation in how we write software today, how we deploy it, how we scale it, how we run it. And to be part of that process is a big deal to us, and and exciting.
And that's the point, isn't it? To make developers' lives easier, to make it so that they can more simply develop the robust applications, the applications of the new era, and so they don't have to worry any longer about underlying infrastructure or cloud technologies. The point of building hybrid cloud across an existing set of IT assets integrated with a set of public assets, building new hybrid, open hybrid clouds that deliver massive scalability with elastic capability. You know, at Red Hat, you've heard us say it a million times, we believe that through open collaboration, the community can build better software, right? So what started with Red Hat Enterprise Linux is now into spaces like virtualization, cloud computing, software-defined networking, big data, and platform as a service. So it's a journey that for us began over 20 years ago, and on a daily basis, it's redefining IT and unlocking innovation. So we wanted to thank you for being here. Thank you for coming to the Red Hat Summit. Thank you for being a part of the community and what I think all of us believe is perhaps one of the most interesting times in information technology. Thank you.